Yes, this is another good question we have. Again, relation is going from natural cross natural to natural cross natural, and the relation is AB relates with CD if and only if AD into B plus C is BC into A plus D. We have to show that this relation is again equivalence relation. So when you start with the equivalence relation, this is first we go for reflexive. In reflexive, we will start with let AB belongs to n cross n. And what you have to show in the question, we have to show that AB relates with AB. Now check here what it says. It says first element and last element should multiply, that is A, B. And then these two element, middle element should add, that is B plus A, equal to. Here it says BC, that means these two will multiply, that is BA. And then the outer will be adding A plus B. Is something new we are getting, just check here. AB is here, BA is here. You can write it. B plus A plus B. I can write it. So we write we know. What do you know? AB into B plus A should be equal to BA into A plus B. Nothing new we are writing. This is for natural number. Product of this commutative here. Addition again commutative here. What does it mean? This implies we'll say AB relates with AB. For all AB belongs to n cross n. And therefore, what I should say R is reflexive on n cross n. This is the first thing we got. Now coming on second condition, that is symmetric. This is okay. Now we are coming on symmetric. In symmetric, again two elements. Let AB and second is CD belongs to n cross n, such that, what is the condition? AB relates with CD. AB relates CD. What conditions is here? It is given A D into B plus C comes out to be BC into A plus D. This is given in the question. Now this implies what you want in the question. Now I want that it should be this way, that CD relates with AB. We have to prove that CD relates with AB, means I have to take first CB into D plus A, and then it comes DA into C plus B. This is the result we want. Can you get it? BC and A plus D. BC and A plus D. So this term I'll take this side first. BC into A plus D. Then here it is AD into B plus C. BC you can write as CB, no problem. And this you can write D plus A. And AD can be written as DA, and this will be C plus B. And when you got this, what it indicates, that AB relates with CD. For all AB and CD, sorry, this is wrong, we have written, this is CD relates with AB. For all AB and CD belongs to n cross n. Therefore, what I should say, R is symmetric on n cross n. So this relation is symmetric on n cross n. Now coming on next part, transitive. In transitive, we'll start with let AB, CD and EF belongs to n cross n. Let AB, CD and EF belongs to n cross n such that AB relates with CD, first one, and at the same time CD relates with EF. What does it mean? It comes AD into B plus C will be equal to, this will come BC into A plus D. And here what you have, just check, C into F into D plus E is equal to DE into C plus F. So these are the two results we got. And from this, what result you need, that to be checked now. I want the result to be AB relates with EF. We want this. And if AB relates EF means AF into B plus E we want, and then BE into A plus F we want. So this result we want in the question. A is here, B is here, E is here, F is here. C is missing, D is missing. Now to get this, directly if you try, it will be a difficult job to do. Best way to do this question is, we'll separate the variables. How we do it, just check. B plus C by BC I write as A plus D by AD. And at the same time it will be D plus E by DE will be C plus F by CF. And when you solve it, it will come B by BC plus C by BC come out to be A by AD plus D by AD. And at the same time D by DE plus E by DE equal to C by CF plus F by CF. Now when you solve it, what this result comes, just check here, B cancel out, so 1 by C plus 1 by B comes out to be 1 by D plus 1 by A. This is the first part, and at the same time it will be 1 by E plus 1 by D equal to 1 by F plus 1 by C. Now this is the result we got first, and I want that B to be removed in this question and D to be removed here. So to get this, we add it now. 1 by C plus 1 by B plus 1 by E plus 1 by D comes out to be 1 by D plus 1 by A plus 1 by F plus 1 by C. Something cancel out, just check here, 1 by C gone, and then 1 by D also gone. Then left is B, E plus B, and here it will come F plus A by AF, or I should say E plus B into AF. Just check here, AF, B plus E I can create. Then it comes BEF plus A. Simply interchange that AF, B plus E should be equal to BE into A plus F. From this, clearly what I get here, I got here A, B relates with EF. For all AB, CD, EF belongs to n cross n. And as you got this, what I should say, therefore R is transitive on a n cross n. And if it is transitive, thus what I should say, R is equivalence relation on n cross n. Hence, so this is another good question we have, and this also we got in 6 marks question, so you should proceed this question also. Now taking some question in which contradiction to be given, and this already I have discussed, in contradiction we are going to have. Means in this case, till now we have done the question in which we have just checked whether it is an equivalence relation or not. We have not checked that. It is already question says that you prove that it is an equivalence relation. Now the question will come, check whether these are equivalence relations or not. So that will be the question we are going to have now. Yes, this is the second type of question we have. Third type only. First, we have done those questions in which we have proved equivalence relation when single set was there. Now, this is the second question we have done in which the relation was equivalence, but set was the Cartesian product form. And now we are coming on the questions in which we are going to check whether this is reflexive, symmetric, and transitive or not. This is a relation defined on real number. Relation is defined on real number. And this is denoted by R1, and what it says, it is related if A is less than or equal to B. Then we should have relation is valid, and we have to check whether it is reflexive or not, symmetric or not, or transitive or not. First thing, let A belongs to R, real number set. Every A will be less than or equal to A, nothing wrong in it. So we should say we know A is always less than A. This is valid for all A belongs to R. Therefore, R is reflexive on R. R1 is reflexive on R. So we should say A plus, one step also missing here. A less than or equal to A. For this implies we will say A belongs to R1. For all A belongs to R, therefore R is reflexive on R. First part we have completed. Now coming on symmetry. Symmetry says A is less than or equal to B, then B is less than or equal to A, or no. Just check here. So we will take two elements, simply let 2 and 3 belongs to real number. Let नहीं लिखेंगे as 2 and 3 belongs to real number. Then first thing is clear that 2 is less than or equal to 3. But if I interchange that, 3 is less than or equal to 2, which is not valid here. So here in this case, then 2 is less than 3. This implies 2, 3 belongs to R. We have this. But when 3 is less than or equal to 2, it is not a valid case. So this implies 3, 2 does not belongs to R1. So 2, 3 belongs to R1, but 3, 2 does not belongs to R1. Therefore, what I should say, R1 is not symmetric on R. This is the condition we should keep in mind. Okay. Now coming on third case, that is transitive. We should check. In transitive, what we are going to have, just check here. A, B, C. It is valid because A is less than B, B is less than C. Automatically A is less than C. So let A, B, C belongs to real number such that A, B belongs to R1, and at the same time B, C belongs to R1. What does it mean? This implies A is less than or equal to B, and at the same time B is less than or equal to C. And when A is less than or equal to B, B is less than or equal to C, it is clearly shows that A is less than or equal to C. And what does it mean? It shows AC belongs to R1. For all A, B, C belongs to R. Therefore, what I should say, R1 is transitive on R. So we should say this relation is reflexive. This will be transitive, but not the symmetric one. So this way you will be having one example in which you will say relations are not completely equivalence, or we'll say two cases of the equivalence are valid, but third is not. So that's why it is not called as an equivalence relation. Next example. So this is another example. Relation is on the real number. R1 is defined as AB where A is less than or equal to B square. This is another good question. This example you should remember. This will be valid for any number which is greater than 1. If you take 1 less than 2 square, 1 less than 1 square. Here in this case what we have to prove? 1 is less than or equal to 1 square. 2 is less than 2 square. 3 is less than 3 square. It is a valid case. But by the way, if I take half and it is half square, what you will find, it is not valid. So that means it is valid for numbers which are 1 or above it. But when you take the number between 0 and 1, it fails. So what you should say here in this case, as half is a member of real number and half is not less than half square. And what does it mean? Half and half does not belongs to R1. Therefore, R1 is not reflexive. One thing is clear. One relation is not reflexive. Now we think about the symmetric. In symmetric, what we want, A relates with B, then B relates with A. Is it necessary or not? For example, we start let minus 3 comma 1, or we take minus 2 comma 1 belongs to R. We'll take 1 comma minus 2. 1 comma minus 2 belongs to R. Then we know 1 is less than or equal to minus 2 whole square. What does it mean? 1 and minus 2 belongs to R1. But when you take minus 2 this side and this is come out to be 1 square, is it valid? Minus 2 is less than 1 square. Yes, it is valid. So something wrong we are doing. One more example we should try now. Can you try? 1 and minus 2 we have taken. If I take this, 1 is less than or equal to minus 2 square. So slight problem we are getting. Better is you to take this minus 1. If we do this, then what we check here, just check here. Minus 1 is less than 2 square. Agree on this? That means minus 1 and 2 belongs to R1. But when you take 2 this side and this side, it will be minus 1 whole square. This is 1 and this is 2. It is not valid. So that means 2 comma minus 1 does not belongs to R1. Therefore, what I should say, R1 is not symmetric on. Now coming on transitive, this is the last case. In transitive case, we will take an example. 2 minus 3 and 1 belongs to R. Then first condition is 2 is less than minus 3 whole square. At the same time, minus 3 is less than 1 square. So we will say 2 comma minus 3 belongs to R1, and at the same time minus 3 comma 1 belongs to R1. But what you will find, 2 is less than 1 square is an impossible case. When you do this, that will be 2 comma 1 does not belongs to R1. Hence we will say not transitive. And as the relation is not transitive, we should say it is reflexive, no. Symmetric, no. Transitive, no. Next question will continue.